Hey, hello, engineers, and welcome back to the DevSecOps series again. Now, you might have wondered and seen a lot of times that currently in this particular phase of technology, we are using some kind of architecture which is called as microservices based architecture. Now, one of the very key component of this particular architecture is what we call as API. And what is this API? How do developers build it? How is it consumed in the different softwares? And now, ahead of that, how do we provide the security to this particular APIs? So that is what our today's topic is all about. So we will be learning about what these things are, what are APIs in layman terms. Then we will see about what is the stuff that could harm your APIs, and then we will see about some of the uh, things that we can do to secure your APIs. So that's what all today we will be looking about. And until now, we have covered a lot of different topics you can see in our playlist. I'll link it in the description over here. And let's start with our today's video. So, the very first thing we will be learning about is what is API, just so you know that you don't know APIs and then directly learn API security. So, this should not happen. We will just walk through what is a basics, meaning of creating an API. What is the function of creating APIs, and how do they serve in a multi-tier architecture solutions? So that's what we will learn in the beginning. Then we will learn about API security. Okay, what are the different key aspects of API security? What are the common threats to this API? Stuff, and we will see what are the OWASP top 10 in that particular sense, and then we will learn about what are the different particular API security tools that are being used in the market overall. So let's first see. I'll just dock myself a little bit over here. What's the best place to be in? Cool. So the very first thing regarding API, what is API? The full form stands for Application Programming Interface. Okay, so it's kind of interface that we want to use or we want to consume. Now, why is it used for? So, let's say consider a multi-tier application, okay, front end, back end, and database. So, these are three components. Now, consider yourself sitting in a restaurant. Okay, you being a consumer go into a restaurant, sit on a particular table. Now, you want to eat something basically. That's why you go to restaurants. Now, how would you get your food? Okay, that is the main concern for us. How are we supposed to get our food so that we could eat or we could consume that thing? So there is someone called as waiter. Waiter comes up to us, gives you the menu card, and says, "Here is the menu, and this is what you can order." So basically, you will check the menu list of what things you can order in this particular restaurant. Then based on that, you say, okay, bring a Manchurian or pav bhaji to me, dear waiter. Waiter lists that particular thing down as your order, and then goes to the chef who is there in the kitchen, and he tells them to cook or make this thing Manchurian and pav bhaji for you. Now, after the cook or the chef makes your dish, then the waiter brings it along with him in his hand, and then he serves it to you, okay, on your table. So that is the general flow of what we see in restaurants. So first you see the list of whatever the consumable things that are there. You ask it or order it to the waiter. When the waiter goes to the chef receives the order. Chef then prepares the meal. Then this meal is handed, like chef will not come to serve you the food. It's basically the waiter who will do this thing. So waiter will bring it up to you, and then you as a user got this particular food to eat. Now, see what things are covered over here. Okay, what components we can relate it to basically in our software or application related concepts. So you can see here, this is a consumer application. This is an application which would serve you something. Okay, this is what basically you are demanding or asking for. And then let me just read it. Okay, this is a consumer application. This is a consumer application. This is the one which will serve the entire uh, you know whatever you request for. Basically it's a server. Okay, and then this particular person is the one who is doing the job of connecting you and the server. Okay, so that is how it is done using this person, which is what we called as an API. So I hope you got the main crux of why API is been built. Okay, what is the uh, function that it serves? It serves between it serves as a communication link between the consumer application as well as the server application or the service application or the endpoint. So that's what we why that is the reason that we build APIs, because it standardizes the process. Otherwise, if you had to go in and tell the chef all the time and then bring your own food from his when he is done, it would be tedious for you to do so. So that is the reason we make use of this particular API stuff that is there. So I hope the idea is clear for you. If not, you can ping me in the comment section or let me know what things you didn't get through this explanation. So what is an API? An API is a set of rules or definitions that allows one software application to communicate with another. Okay, so now basically you standardize this stuff. The menu list is the list that your chef is already trained to do. Okay, so API would say, I mean, the waiter would say, if you go in a veg restaurant and you ask for non-veg dish, then the API would outrightly refuse that, sir, this is a veg restaurant and all our chefs only know to prepare veg meals. So you should not be able to order something non-veg in this restaurant. So that is the job of the waiter or the API. So the request before it is even made on the consumer's end is rejected, because API have a fixed definitions, or the service that you are building have a fixed definition of what it is capable to do. So think of it as a bridge between different system. It defines how requests are made. Okay, so as I mentioned, the request should be made based on the service. Okay, if it is a security service or an authentication service, you would not ask it to place your order in the basket. Okay, so what data is exchanged, okay, and how responses are written. Now in the case that here when he ordered Manchurian, okay, so he told the waiter like, bring me Manchurian. Now he went to the chef and now chef confirms that, oh my god, the Manchurian balls are unavailable, so can you just go back to the customer and ask him to order something else, because I don't have any of Manchurian over here left. So they say like, resource not available, something stuff in the response. And he will say, sir, would you mind replacing the order with something else, or if not, you can go back to your home if you don't want anything else. uh, that would be a bit rude to them, but I hope you get the point. Next is, what is API security? Now how these things could be insecure in that matter. So I know someone could hijack your waiter in between. If he is in the if he received an order from you, and then he like, meanwhile when he is going from you to the uh, chef, someone hijacks him, someone steals him, and that could be possible that your request, even though it was went there, it was not received to the server. That could be one risk. Then one another risk could be that when the chef prepares your meal, someone would come in between and take that particular meal instead of that particular waiter. Now, if he takes that meal, he would add certain poison, maybe if he wants to kill you. So he would, poison that particular meal that is been prepared just now. And once it is there in the transit from chef to you or your table, he would then hand it out to the waiter who was already serving to you. Now, once he, added the poison and then served it to your what's that waiter, and then waiter gives it to you, you eat that food, you consume that food, and then you get infected or you can die in that scenario. So that is what we need to think of, different possibilities of hijacking your API requests and responses. So those are the few things you could already get as a kind of security threat for your API requests. So API security refers to the practices, processes, and tools used to protect application programming interface, the APIs, from misuse. Either someone could misuse them to send some request to the chef to create hundreds of Manchurian, because they could tamper the menu or the order list that your waiter have taken from you. So he would say, instead of one Manchurian, do it 1,000 Manchurians. And then, if the waiter doesn't verify it before handing it out to the chef, then chef would just receive that request and then he would proceed with it. Now, once he have created 100 Manchurians or 1,000 Manchurians, now what to do about it? So that is going to waste the resources that are there on the server's end. So that kind of threat you could pose. So that would come under misuse of your APIs. Then it could attack the example where I have mentioned regarding the poisoning of your food could be the attack, and then there could be a data breach. Now someone got to know that you have ordered Manchurian. Now, instead of going to the same or the genuine chef, someone goes it and steals that data now, and then gives it to different 100 restaurants, and then 100 restaurants prepare it for you, okay, with different rates and different qualities basically. And now they would know that the consumer always requests Manchurian or then other things from you, from the restaurant. So the data breaches could be used or misused in a lot of different ways. So that's basically a kind of threat that your APIs possess. So then, since APIs are widely used to connect services, share data, and enable modern applications, they are also common target for attackers. Now, you know, on the database side, you would encrypt something, so there is nothing much to do. But on the API side, if you do not encrypt or if you do not use TLS, SSL, any kind of protocol, then everything is basically transferred in a text format, hypertext transfer protocol, right? And if it is not secured, then your data could be visible when it is traveling from one point to another point of the network. So network basic, I mean, the communication happens using the network hops. And if there is some kind of attacker in one kind of network hop, then it would be visible to you. Like, you know, there is broadcasting of signals. And unless and until you have source and destination IPs set properly for your API requests or your network configurations, then it would be really difficult for any kind of network to know where to send it. It is going very deep. Keep it aside. So if you know how to manage source IP and destination IP in any kind of communication, network communication, and then if you know how to spoof or how to copy someone else's IP address, so what will happen? There are two IP address with the same. I mean, there are two different networks with the same IP address or two devices. Now, what will happen once the source, let's say the database, sends the uh, information to that particular IP address? Now, the network gets confused. I see two different IP addresses or two devices with the same IP. I will send it to both of them. Let's see. Okay, now the data is being breached. Someone else also got the hold of data. So that is a kind of possible scenario you could go through. So that's why protecting your API is really important for modern day applications. So it is really fragile and easy target for us to do it. I would show you someday, but it would be really heavy for you guys if I say. I would link it somewhere maybe. So then comes next slide, wherein we would learn a bit about what are the different key aspects of the API security. So you remember I have already shown this in the really first slide. So you can have it as a mind map. I'll show you that thing again. Okay, here you can see OAuth encryption, log and monitor, rate limits. I don't know if you can see use HTTPS. Uh, I'll bring myself over here. Use HTTPS, then security testing, and then update a patch and input validation and all these things. So you can do a lot of these things to enhance the security posture of your applications. If you don't do it, don't expect any security for yourself or your consumers in that matter. So now, authentication is one thing, authorization is another thing. A lot of you might have heard this particular question in your interviews in case you are giving it for a security role or an application developer role. What is the difference between authentication and authorization? So we will learn it in a bit. Then encryption as well as input validation. These are the few things you can focus on when you kind of deal with APIs and to secure them. So starting from the beginning, what is authentication? Authentication means verifying the identity of a client, okay, either a user, service, or application who is kind of trying to access your APIs. And authorization, it means ensuring authenticated clients can only access resources or perform actions they are allowed to. Okay, which is basically coming under the roof of role based access control, which is RBAC, or attribute based access control, ABAC. Now, talking about the differences first, authentication. Consider uh, you are going to enter in a building, okay, and it has a security checkpost in the beginning, wherein they would ask for your identity. Okay, so okay, let's talk about a school or a college. So now it is an engineering college, and the expected users or the people who are allowed to enter the premises are students of engineering. Okay, now what kind of engineering? It would depend on the college. Now, once you are on the gate, you go to the security guard and ask them to allow you to enter in the college premises. Now, they would ask you for identity card. If you have the ID card, then only you are allowed to go inside the premises. Okay, that's one thing. So that is authentication, to authenticate the validity or if this user is even allowed to consume whatever there it is inside. So verifying the identity of the client and then only allowing it to enter into your application or your APIs. Now, once you are there, you are authenticated. Now they would check what kind of permissions do you have. If you are a computer science student, you should be only uh, you know going to the computer science lectures. It should not happen that you are sitting in a commerce lecture in that particular engineering college if there is a commerce section, or if you want to go somehow in many mechanical or civil branch classes or lectures. So you should not be allowed to do that because that is a bad practice. And as per you, you are a computer science engineering student, you should be only allowed to go into computer labs or the lecture halls that are allowed for computer engineers. So that is the level of permissions you are supposed to have as a user. And if you violate that thing, you should be directly blocked. You should be, I mean, the teacher should be directly throwing you out of the class if they find that you are a computer science student attending a civil engineering class. Just so if you have a crush over there. I used to do that. Whew. But I am from civil. I used to go in computer engineering classes. Don't tell it to anybody else. I might cut this, but I think I would not, because that is a violation that we have already done, and we know what is the level of security in that case. So that is what is the difference between authentication and authorization. Authentication, it means to verify the identity. Authorization, it means to check the permissions, if you have the authority to do it or not. If you have the permission, you do it. If you don't, you block it. That's simple. So using OAuth 2 or OpenID Connect, OIDC. Okay, or if you have heard it, OID and then C. These are the kind of authentication stuff that you could do, uh, implement on your APIs or your users or your applications. And then there are Java, JSON Web Tokens, JWT. Okay, why did I wrote tokens? JWT tokens. Okay, JSON Web Tokens. Then authorization, ensuring authenticated clients can only access resources or perform actions they are allowed to. That is the most important thing. That is why you might have seen in IAM people who allow or deny certain permissions to certain resources. So that is why identity and access management is a key part of security, basic security, fundamental security of your applications. Let me go over there. Then encryption. Now protecting data in transit. Uh, you know Using TLS, transport layer security, or hypertext transfer protocol, which is secured at in transit and at rest. So as I mentioned uh, earlier, that your data could be hijacked and changed in case of, if there it is in the server side, in the data storage side, or whenever it is coming to you, or whenever it is going towards the server. So remember when I told you, waiter takes your order, one Manchurian, then it is modified to 1,000 Manchurian. Now it goes into the service, okay, or the application server. Then the application server processes, creates 1,000 Manchurians. Now what to do about it? Okay, because you only asked for one. So that is kind of man in the middle attack. It could be possible, to tamper. I mean, it would be tampering the request basically. Okay, and then there is an MITM attack, man in the middle attack, wherein told you that uh, if the chef creates one Manchurian, and then someone, while it is going from chef to the consumer, it is poisoned by some third party actor, which is called as a man in the middle. Okay, in the middle of requests. Okay, so that could possibly happen, and then it would be destroyed, or you as a consumer could be damaged with that particular act. So uh, that's the thing that your encryption would secure for you. Now consider the order that you placed earlier. Now you locked it in a particular case, and you only gave the, I mean, you have one key which unlocks it. It is in the box. Now the uh, what we say, the waiter takes that particular box of order and then goes to the chef. Now chef has another key, okay, which is now only used to open that box. So that is decrypting that thing. So then it opens that particular order box and then checks, okay, now this is the order. Now while sending, like, he will prepare the order and then he will send it to you. So while sending, he again packs it in a box, lock it with the key, and then again the box reaches up to you, and then you open up the box. Okay, so with the key that you have basically. So that is what encryption means. So encryption at rest, encryption in transit. So what we talked about, this locking of the box and the parcel, it is basically the encryption in transit. Okay, not encryption at rest. Encryption at rest would be happening with the what we say, with the server or the client. But this is where encryption and decryption plays when you talk about network communication. So that is going from one place to another place. Okay, protection of data in transit. Then, oh, it's enough of concepts for you guys. I'm not sure if you would be able to consume it in just a single day. You can watch it in parts. So authentication, authorization, encryption, then input validation. Now whatever the inputs that you are giving would be validated by the server or by the APIs to protect against injection attacks like SQL XSS command injections, and validate request data formats, lengths, type. Now, as we earlier mentioned, that someone gives a request to the chef, create 1000 of Manchurians. So server should be able to validate this particular thing. Like, is it even allowed, or is it even possible for them to do that thing? So that is input validation. You would basically check the authenticity of a request which is made, and you would check if there are some malicious scripts that are injected in the um, you know API request. So that is what input validation. I mean, it would go long if I try to explain it, but okay, cool. Next stuff is rate limiting. You would highly want to limit how many requests your application would get in a matter of a minute or in a matter of a day. If there are 1000 customers that come into your hotel on a given day, your AP, your chef would be overwhelmed, and then he would be crashed. He would overwork and crash basically when you serve this request. And imagine he created 1000 Manchurian and no one came to receive or eat that particular thing. That is basically wasted resources. So that is the stuff with the DDoS distributed denial of service stuff, wherein there are different chatbots who kind of requests in millions or billions of numbers to one particular API, basically giving no access to other, and then those are all false requests just to overwhelm your servers. So that is basically denial of service kind of attack. We will uh, learn a lot of different types of attacks in the series, where we are going to cover about the types of attacks that are possible. So that's why I always ask you guys to, if you encounter one particular concept, then you should check it on your own later on, because I'm limited on my time to explain all of this stuff in great details. That's why I just touch upon them and then hold myself back. Then brute force and then credential stuffing. You can search for it. Now, controlling the number of requests to a client that a client can make within a time frame. So if only 10 requests are allowed, the chef could be possibly doing it in half hour, 3 minutes for each dish. But if thousands are there and you only have 24 hours to do it, a limited time frame, God forbid, what will happen if you start creating those requests and serving to these kind of false requests? Then logging and monitoring. Now you need to track your API usage, and you need to make sure that mm, uh, you know there are no unusual activities that are possible on your APIs. That's why we want to embed security in it. So once you log and monitor your APIs, then only you will get this kind of information. Otherwise, if you just create your application and then deploy it without any basic logging or monitoring stuff, then you would never know what is happening with the application, what kind of things it goes through. Okay, and what kind of requests people throw at you. Then detecting anomalies such as excessive failed login attempts could be one stuff that you would ask for. Then error handling would be avoiding the exposing the sensitive system details in the error messages. uh, if someone makes a false request and then you give them the response that, oh, it is not a genuine request and it failed at this point on this server and this location of this API or this IP address, then you are disclosing certain sensitive information regarding the application that is being hosted, that the API is being requesting to. So that's why you need to make sure that you do proper error handling And then in case of certain malicious inputs, it doesn't throw out any sensitive information in that case. Then security testing should be enabled for your application so that you would basically know when your application breaks at certain points. So that's about it. And then was top 10 security risks. What are those? We will just see. So our list is long. Broken object level authorization, as we already mentioned earlier. Authorization you need to know based on the RBAC stuff that we already discussed. Then broken authentication could be a risk. Okay, here we are talking about risk, security risk for your APIs. Authentication, then broken object property level. So if someone could inject different properties, they could elevate their access in the authorization steps. So you need to verify the properties as well. And then unrestricted resource consumption, as I mentioned, if someone asks you to create 1,000 manchurians, that is an unrestricted resource consumption, and you started to make 1,000 manchurians. So your consumption capacity now its capacity should be restricted. You would be only able to serve 50 manchurians in a day. That's what is the resource consumption capacity. So you need to restrict that particular thing, otherwise the server side would blow up as hell. Then broken function and for function level authorization, same stuff with the granularity regarding the functions. Okay, if there are any kind of function that could be invoked using your APIs without authentication, then you should see if that is not much critical or if that is not serving any harmful data as such. So you need to have this object level authorization, what object someone could um, be able to access. And then function level authorizations, then unrestricted access to sensitive business flows, data flows from one endpoint to another endpoint. Then you should be aware of this business flow, how the data flows from your front end application to your back end application to your database. If you do not know how that flows to and fro from these particular components, then you are basically cooked. Cooked, not crooked, sorry. And then if someone gets unrestricted access to that particular thing, that particular flow, a lot of data would be given out. Consider your bank. If you have a lakh rupees, $1 million in your bank account, and someone got the hold of the customer ID of your account, and then somehow they also got to know, because password is saved somewhere, they got to know that this password is saved in one particular database, and then they got that particular password. They could access your money easily using your user ID and password, and they could transfer it to someone else's account whom you don't even know. And that's how basically you lose all your hard earned money. Unlike me, I just sit and earn. Okay. So that's what you need to be aware about: the business flow, the data, and the access to it. Then server side request forgery. Forgery, it means something to modify and then make it malicious, which is done on server side. Uh, then there is client side request forgery. Someone could tamper with your API requests or calls. Then security misconfigurations. Then improper inventory management and unsafe consumption of APIs. Oh, a lot of different things. And now you can, go to this particular OWASP org API security uh, link, and you can find out some more stuff about how to secure these things. So that's one stuff you can browse. I'll give this link in your the GitHub account that we have. You can see it in the secure links, or the links, important links section in our GitHub. Okay, instead of that, I will just show you in a bit. I would go to github.com/, I cannot see my board. Manthan, let me not see the board. I'll just go right away. So here in the DevSecOps series, one more stuff. So here in the DevSecOps series, you can go over here. You can get the slides. I mean, get the PPTs from here, and in the important links section here, you can go to the. Oh, why did I not give it? Application security verification standard. You can see there are a lot of different things, and you can go was on that particular link. I'll add that link over here. Was API security, and it would land you to this particular project. And from here, you can see the broken object level authorization and all of those things. And this one, I think it is the one that I have given the link for. Yeah, where it is table of contents. And I think it's this page. Nope. What's the page? Editions 2023 0x 11. Oh, oh, 11 hyphen T10 hyphen T10. Oh my god, you got this over top 10 API security risks, and you can see, okay, the description of these things. Okay, I just copy pasted it, don't worry. Okay, yeah. Where do I get all these things from? All of my knowledge. It all comes from the official websites. I'm not creating everything from my own mind. So yeah, those are these few things, and then let's go to the API security tools. Now, these are the most popular tools that you can, try out for, and we will see Burp Suite as well as OWASP, Zap, and Mayhem API in our upcoming lectures or episodes, whatever you want to call it. And we will see how to use these particular tools for securing your application, for launching DAST, uh, which is dynamic application security testing stuff, using OWASP and Burp Suite. Burp Suite. Why do I always call it Suite? Then API Sec and Mayhem API is particularly for APIs. If you have them on your local machine, we would test it, or if you host it somewhere for your services, you can also try out that. So we will go for the tutorials later on in our series, but make sure that you are aware about these things. So here we come to the end of our today's topic, which is for API security. I'll just briefly tell you what we have covered up till now. We have covered threat modeling, we have covered SAST, we have covered SCA, we have covered security is the next. Secret detection, we have covered MAST, we have covered API security, DAST, IAC and CM, IAST, RASP, and I think WAF is still remaining. Weird. I added few more topics to it, as you can see uh, over here. DLP, which is data loss prevention, ASPM, which is application security posture management, CSPM, which is cloud security posture management, SOAR, which is security orchestration, automation, and response. Um, CM is, I think, already added. Pen test and cloud security. So these are the different things we would be learning about in our upcoming videos. And until then, I hope if you like this particular stuff, then please do like, share, and subscribe to the channel, and share it with your friends and people who want to get into security and learn something about it. So if you are not even learning, I mean, if you are not even trying to get into DevSecOps, just at least get to know what different things are available in the market and whatever different threats that are there. Like, majorly what we cover in our entire series is different type of things that are there in the application life cycle, software development life cycle. Then different tools and technologies that use, like infrastructure as code, configuration management, CI/CD, uh, uh, IDEs. Okay, these are the technologies that you consume. Again, you use cloud architectures. You use cloud components. Then you have your API, front end, back end, web application. Console application, console based application. Uh, what's that? Firmware or anything. So there are different kind of components all around you, and you need to know how different kind of attacks that we discuss are possible on different components. Okay, and then how they can lead to exposure of data, of your private data, of your something that is related to you that could harm you potentially. So these kind of things is what we discuss the components, we discuss the phases, stages where they are deployed, we discuss how they are used, we discuss then how they could be attacked, and what kind of data could be breached, and what kind of uh, you know possible damage could occur to you. So that's why it is in general study, particularly regarding security. So I encourage all of you to go through these things, and just we also discuss how to test them and how to defend against these kind of attacks. So a lot of things is what we cover in our series. So that's all for our today's API security stuff, and we will meet again in another video for something which is called as CI/CD and its security. So until then, keep learning and bye, guys. And I hope you keep learning as you are doing over here. So that's it for today. Bye now.